us try this example. You are asked to find the inverse Laplace transform of these functions. Referring to the table or formula, you will obtain this. You will need to convert these functions in the structures of this in order for you to identify the a and omega in the functions here. These functions can be rewritten in the form of this, where 4 plus 9 will be equals to 13. Factorize this, you get s minus 2 power of 2, and the 9 here can be presented in 3 power of 2, and based on the structure here, in comparisons to the formula, you know that omega is equals to 3, while the a is equals to 2. Substitute the omega and a into the functions, you obtain this. Next, you are asked to find the inverse Laplace transform of these functions. Referring to the formulas table, you obtain this. What you need to do next is rearrange the function here so that it more closely resembles this for you to determine the a and omega. Based on the formula here, the relationship between s and a are always in the negative form. However, here appears in the positive form. This can be rewritten by s minus 1. It will eventually give you the same outcome of s plus 1. This can be rewritten in this manner, where 1 plus 9 is equals to 10. Factorize this, it will be something like this, and the 9 here can be in the form of 3 square. Compare the functions here. You will get a equals to -1, while omega equals to 3. There is a factor of 2 here. Remember to bring forward the factors and substitute the relevant value of a and omega, and you get your final solution. Let us try this example. You are asked to find the Laplace transform inverse for these functions. From the formula, you will get this. Your next step is to rewrite the function here so that it matches the structure here for you to identify the omega and the a. Take out the 5 and rewrite the function here, where 1 minus 4 will give you -3. Factorize this, you will get this, and the 4 here can be represented by 2 square. You need an omega, which is 2 here, so when you add up 2 here, remember to be divided by 2 so that this 2 will be cancelled out. Now compare the structures. You know that omega is equals to 2, while the a is equals to -1. Substitute the relevant value into the formula. Keep the constants. You will get your final solution. Next, you are asked to find the inverse Laplace transform of these functions. These functions can be expanded into 2 functions, which in reference to these 2 formula here, there will be s minus a and also omega. Here you have to get rid of the 4 here. These functions can be rewritten in the form of this, where 4 multiply -2 will give you -8. This will be cancelled out by the 8. So that ultimately it will be equals to 4x plus 3 as given in the original function here. If you solve this, you will get 4s minus 2 plus 5. Now we look at the division part of the functions, which can be rewritten in this manner, where plus 4 minus 9 will give you negative 5. This can later be factorized into this. What you see here, you can actually expand this into two different functions. That give you this. Bring out the constant 4 here and compare this with this while comparing this with this. In comparison of these two functions here, you know that the a is equals to 2 while the omega is equals to 3. Substitute the relevant value, you will obtain this. You have a constant number in front, and compare this with this. You know that the omega now is equals to 3 while the a is equals to 2. Substitute the relevant value into the solution here. You will obtain this, and remember to keep the constant number. This will be your final solutions. What you see from the examples that we have done, it is sometimes difficult for us to judge which formulas to be used from the tables of Laplace transform, especially when involving the s power of 2. This shall involve a lot of trying and error, and this trying and error will allow you to change and modify the structures of the functions until you reach to a case which more closely resembles to any of the formulas in the tables. From there, you are able to determine the solutions of the inverse Laplace transform.